find what he had found was a company that takes multiple components, puts those components together into one system that hopefully works seamlessly and accomplishes the goals of what was set up to get the product out the door, or increase productivity, or reduce manpower, or whatever the reasons were for putting together the system. A couple of drawings here that we've thrown up. This is a distribution center with some carousels, some conveyor, there's some racking in there. Looks like there's a consolidation area over towards the end of the system there. So, you know, integrated system, something that takes multiple components. This one's a good example. There's rack, there's fork trucks, there's carousels, there's conveyor, there's a flow rack. Lots of components that all have to work together. At the end of the day, we need to work together seamlessly so that we accomplish the goal. This looks like a 3D view of that center that we put together for Mr. Black. Well, let's get that back there. So the comment was a little unusual to have carousels and flow rack in the same center. I guess I would say, depending on the throughput of the product, the size, the SKUs, and the cube that's required, products can fit into different picking storage mediums based on those volumes. So in this center, for example, you've got certain products that are high volume, large cube requirements for a week's worth of picks or 2 weeks worth of picks, and so those might get slotted into a flow rack system versus all the other products that may fit into the carousel based on cube and SKU and that kind of thing. So in the volumes there, I think in this system, over here, this is a flow rack zone there. We picked the light on it. And of course, then they've got horizontal carousels here. And it looks like down here we're using some flow rack at this end for consolidation. So orders are coming down the conveyor system. They need to get consolidated together. They're using the flow rack at the end of the system to bring those orders together as a consolidation zone. So a little mix and match of use of technology there based on the different criteria in the items. Part of the job of the integrator is to actually work with you to figure out what that is and how those different storage mediums work within that distribution center and how they can work together. So typically it's not all one or another solution for the distribution. This is a picture of an automated production line that we designed for some company that we threw in here. So just a manufacturing piece to kind of go along with the distribution piece. I know this whole scope program is put together more around distribution and logistics and manufacturing. So the role of the integrator, we just kind of talked about this a little bit. You know, understand the business of the customer, design the responsibilities and the roles of who's going to do what within the organization, and bring all that together into one cohesive system that we've integrated for the company. Catching up here on some slides. So you know, take a clean slate of paper. So an integrator really should take a look at what you need from a customer standpoint. Each customer is different. Each system is different. Each company has different requirements of what they need and what they need to accomplish at the end of the day. So try to take a clean slate of paper. Don't have any preconceived notions of what it is that you need to supply. We don't need to supply conveyor because we don't build conveyor. We don't need to supply carousels because we don't build carousels. We don't have to supply pick-to-light or flow rack because we don't build that equipment. So the idea is we can come into the system, we can take a look at it and say, okay, what's the best tool to solve the problem without having to take a look at every one of those. You know, we've got to build the next number of feet of conveyor to keep the factory busy, so we're going to sell you a lot of conveyor. And that's the role of the integrator is really not to do that. So, the role of the integrator is, you know, let's figure out exactly what it is that you need and fix that first. And I'm going to go through some of this integrator stuff and get into the meat of this project. So a couple of different phases of the design of an integrated system. Very important to get a design phase done. Let's figure out exactly what it is that you want to do and develop a design criteria. So I think part of the thing that Tom had learned through his experience is that they kind of rushed into the project and said, okay, this is what we want to do. They didn't spend a lot of time in figuring out exactly what the design criteria is. At the end of the day, what it is that you're trying to accomplish and what the goal is of the solution. Where are you trying to get? And I think it was kind of put together in a mismatched way of doing the business. And so what ended up happening is he ended up with a really nice system in the middle of a warehouse, but the rest of the system really didn't fit into it. His manufacturing process didn't feed into it very well. So I think part of the lessons that Tom was trying to get across here, and I think there's some slides that will kind of go through bullet by bullet on that. Take the time up front, make sure that you actually come up with a design criteria. Work with your integrator to figure out exactly what it is at the end of the day, what the goal is, what do we want to accomplish. And make sure you look at all the other pieces that go into that. So it's not just the box in the warehouse, it's the stuff that feeds the warehouse, and it's your customers at the other end that get the stuff out of the warehouse. So the design phase, preliminary design, and then the detailed design. So when you're all said and done, you want to have a set of drawings that are all very well laid out and a description of operation of how this thing is going to run right down to the T. So you know all the processes that have to happen and how everybody's going to work within that operation. Good project management. I think there's some slides that will follow up behind this stuff that will kind of fill in there. So project management. And then the implementation phase. Make sure that we've got good guys out there to implement this project. People that are willing to work within the area. You're doing business in the building. Everybody doesn't have the luxury of having brand new facility to set these systems up in. So sometimes you're trying to do this within the organization, within the building that you're working in, and you got to keep the business going while you're integrating a full system. So it's like changing the engine in your car going 70 miles an hour. We got to figure out how to do that. A good integrator will help you through that process. They'll help you figure that out so that you can continue to ship product and install this equipment that you're about to put in. So once you pick your integrator, this is kind of where we were talking about the detailed design on the front end and having a design criteria. So once you picked your integrator, once you found somebody out there that you're comfortable with, somebody that you think can do the job for you, spend the time on the solution. Spend the time up front. Don't just come out there and say, okay, now we've got an integrator. Let's buy a bunch of equipment and throw it into the building. Spend some time working with that guy or that company to figure out exactly what the ultimate design is going to be for you. And I think working together, you can't do it in a vacuum. You can't have the integrator go off and do it in a vacuum. They can't design it. They don't know your business. And as a company, you're probably not the expert at designing the automated system, so you need to work together, and that needs to be a collaborative effort. Involve the employees. I think one of the things that Tom was trying to point out there is that the employees have lots of good ideas. So if you bring those folks in up front, you'll get good ideas out of those employees, and you'll get buy-in to the system. One of the worst things that you can do is dump the system in with a bunch of employees, and then they come in and go, well, this isn't going to work, and then they've shot it down before you've ever turned the thing on, and it'll just be a failure. You'll just struggle getting those employees to buy into the concept. So if you get them involved early on in the process, try to pull some ideas from those guys, you get some buy-in from your employees, that'll make the implementation go a whole lot easier. In the preliminary work, you got data collection, data analysis, access review. That was something that I think Tom missed big when we did the system for him down there. We worked together with him. There was a lot of access inventory, stuff that didn't necessarily need to be in that building. And I think what he found out is over a period of time, we designed the system to be able to handle the inventory that he had there. and didn't take the time to review all that inventory they had there to figure out that with this new system that he's going to have in the building, he doesn't need to have all this inventory. He can make the turns a lot quicker, so he could reduce his overall inventory. That was something that he figured out. Develop a good project schedule. Develop a realistic project schedule. So many times corporate folks will say, okay, we've approved the contract, we've given you your CAR, we've given you the money to spend. We want it spent in 6 months, and if that's not a realistic time frame, you got to push back on those folks and say, listen, we can't do this in 6 months. It's a 9-month project, and the guys that are spending the money sometimes want to start to see the ROI as quick as they can. That may not be realistic. You may not be able to get that ROI happening as fast as the financial folks want to see it happen. Some of the other things that pop up on projects like an integrated system would be the local review. Fire codes, your insurance carrier requiring sprinkler systems, the unexpected stuff that are going to come up. If you're on the West Coast or in a seismic zone, you've got to have specific reviews for seismic requirements. That kind of thing kind of pop up. If you are in those areas, most of those systems are going to require some sort of a PE stamp. The local towns and counties want to have a rubber stamp on the drawing that says it's been reviewed by a professional engineer so that they're not liable for the issue. So just some things that pop up depending on where you are in the country. Some of these things are required, some of these things aren't required. We've seen projects all over the place where nobody wants to know anything about it. Go ahead and do what you want. And then there's other places in the country where they want it right down to the PE stamp drawings and permits and inspections. Just got to keep aware of what's required locally. Just looks like some data stuff that we've thrown in here, basically trying to do the data analysis, figuring out what the busiest days of the year are. You want to make sure you take a look at any integrated system, and you want to make sure that it can handle the peaks and the valleys for what you're doing. So if you design a system around the averages, and you happen to be in a business that's related to the holiday season, anybody that ships product that's consumer goods, at the holiday season, the peaks take off and shoot right up, skyrocket, so you may do 60–70% of your business in October and November, and the rest of the year the averages. So the average doesn't fall in there, so you have to take a look at those peaks and valleys, and I think that's what we're trying to show there. Some of the benefits you'll get from doing the data analysis is that it'll get your slotting done. So, it's going to be important to slot your inventory in your warehouse so you get your fast-moving parts where you need them, your slow-moving parts where you don't need to get to them quite so readily. So, part of the data analysis, you'll save that information, you'll gather that stuff, you'll put it in the back of your brains, and you'll understand it. When you go to put all this product away, you'll know where it needs to go, how it needs to get put away. Low cost is not always the best value. So, a lot of times what we'll do is we'll put things out for bid. We'll send it out there and say, okay, we're going to put all these components that are in this system, we're going to send that out to everybody. We're going to pick the lowest cost supplier because obviously we're always trying to get the best value. The lowest cost is not always the best value. So it's just a point that I think we're throwing out there. One of the mistakes we made is that we went through the system and we bought this, we bought that, we bought everything based on the lowest dollar amount. Some of those things didn't deliver when they needed to deliver. They didn't show up on the right time. Those things just didn't get pulled together the way that they needed to. So, point well taken there from his perspective. Allow for some contingencies. There are going to be things that get missed. Workbenches, computer stands, totes, carts, pallet trucks. I mean, there's all kinds of things that go into this system that, you just don't get every one of those line items on there. Computer workstations, just things like that. You have to make sure you allow for contingencies. A couple things just